All right. Does this work? Yeah, you can hear me, right? Cool. All right, let me just wait 30 more seconds for people to come in. Is it possible to dim the lights a little bit? Okay, well, I don't know. Well, this should be okay, right? Can you see that okay? It's fine? Okay. Well, let's get started. Hello, everyone. My name is Mete Atamel. I am a developer advocate at Google. I'm based in London. I love visiting countries like Portugal because the weather is always better, food is better, and people are friendlier. So I'm glad to be here, especially after 2 years of pandemic where I was speaking online it felt like to a wall. So it's good to see everyone here. And today I'm going to talk about serverless beyond functions. And what I mean by this is that when we think about serverless, we usually think about functions like AWS Lambda or Google Cloud Functions. And actually, it's much more than that. So what I want to do in this talk is that first I want to do a little bit of history of serverless, like go through the different phases of serverless, how it started, how it evolved, and where we are today. And then towards the end, I want to show you some patterns in the serverless that we have today that kind of works, and with some demos as well. So hopefully it will be useful to you if you are using serverless or if you're not using. Either way, hopefully it will be useful. The slides are already on. So if you want the slides, that's the link. The demos I'm going to show, they're going to be on GitHub. And I'm going to share the links at the end of the presentation as well. So anything you see today, you have access to it at the end of the talk. And if you have questions, please raise your hand and ask anytime. That's the beauty of having in-person conferences. We can have an interactive session, so feel free to do that, okay? All right. Now, serverless, what is it? I don't think I should explain what serverless is nowadays, but just to recap, when we are talking about a serverless service, we can think about it in two different ways. We can think about how we are running our code. So I call that the operational model. And when we are saying a service is serverless, we basically say there's no infrastructure management, meaning there's no servers to set up, there's no machines to configure. So that is done by someone else, so it's not your problem anymore. There's base level security taken care for you, so you don't have to worry about securing the ports or securing, the basic security basically is given. And for me, one of the most important things about serverless is you pay for what you use, right? So it's not like a virtual machine that runs all the time and no matter what, you just pay for it. Instead, in serverless services, you only pay for what's being used. And if nobody uses it, it scales down to zero, you don't pay nothing, right? So that's how you run your code in a serverless way. You can also think about it in how you write services. So that I call that the programming model. And in this model, we are talking about services, so it's service-based. And usually, these services are event-driven. So some event triggers your service. This is usually HTTP, but it can be event-based as well. And I'm going to show some examples of this later. And usually, these services are stateless. The reason for this is that if you have state in your services, then it becomes quite difficult to scale. Because then you need to worry about how do you route users to the same service because it has a state. So usually what you do is that you make your service stateless, you externalize the state. That way, when you need the state, you grab it from externally, but it's not part of your service. So that's what I mean roughly when I talk about serverless. Now, when we look at the serverless history, I think there's 4 distinct phases. The first phase was serverless before it was called serverless. Second, simple functions. That's what we mostly think about serverless when we are talking about serverless. Then the second phase was containers and serverless maturity, because you will see that with simple functions, what you can do is limited. And then we have these things called containers. And there was this parallel universe that existed for a while, but now in the second phase, they kind of started coming together. So we had containers coming into serverless space, and we also started seeing serverless becoming more mature. And finally, today, we see the expansion and integration of serverless. So everything that can run serverlessly, they pretty much do. And then we also started seeing serverless integrating with non-serverless things. And I'm going to talk about more on this later. So let's go through these phases, and let's see what we had, and let's see what we have today. And then hopefully it will make sense in the end. All right, so serverless before it was called serverless. Let's look at that. Anyone recognizes this logo? Anyone? Any guesses? What? No. Well, this is App Engine, and this was launched back in 2008. So it's been already more than 12, well, how many years? A lot of years, basically 14 years. And the goal of App Engine was to make it easy for developers to build, manage, and scale web applications. You would just write some Python, and there was a command line tool. You would deploy the Python, and that was it. Like, the things were basically fully managed for you. You would have this web application where you didn't have to set up servers, you didn't have to worry about load balancers, there was no database to set up and manage. App Engine came with default load balancing and default data store. So in my mind, this was kind of serverless, right? But we didn't call it serverless. We called it fully managed because some of the things were missing. For example, the payment model was not quite serverless. But this kind of started serverless in my mind. So when we look at the state in this fully managed world, this paved the way for the vision of serverless. So people started seeing that it is actually possible to run a service without having to worry about the underlying infrastructure. But it was very limited. So when you look at the original App Engine, it was Python, and later we added Java. But it was just those two languages, and it was a subset of those languages. So you couldn't even do everything you could do in Python or Java. So it was a very subset, it was a very limited versions of those languages. It was mostly HTTP based, not mostly, but only HTTP based. So it was only for web applications. And it was a very limited ecosystem. So if you wanted to use this in the Google Cloud, no, it wasn't even Google Cloud, in the Google ecosystem, you could do it, but there was no ecosystem around it. So imagine you're coming from open source, you're using all this Apache stuff in 2008, and then all of a sudden we tell you we have this new App Engine, come and use it. It was not easy for people to do because people were scared of vendor lock-in, and rightly so, right? You can't just depend on one company for all your infrastructure. And at the time, people were running on-prem virtual machines. So when you have on-prem virtual machines and you tell those people, forget about these, all the investment that you did, and just switch to this fully managed App Engine, that was a huge step, right? So, and there was nothing in the middle. There was no middle ground where people could gradually go to the fully managed, right? So it was either on-prem virtual machines or this thing that runs somewhere and it's fully managed, but there was nothing in the middle. So people didn't want to do that jump that quickly. And that's why Google Cloud was built, and that's why we have all these other services within Google Cloud to kind of fill that gap, basically. So that was like serverless before serverless. Then we had the first phase of serverless, which basically is simple functions. And when you look at this phase, this started in 2014 with AWS Lambda, and that's when we started hearing about serverless. And then it was soon followed by Google Cloud Functions and Azure Functions in 2016. But the idea here is that you just define a simple function. Here's a Node.js function that handles some HTTP request and response, and then you respond with whatever you want, and that's it, right? So you just define this function, deploy it, and that's it. Like, you don't have to worry about machines. You don't have to worry about configuration or anything like that. By default, this just worked. But you had to pay attention to this table. This table is probably already out of date, by the way, but it shows you what languages are supported on what cloud platform, and not only that, what versions of those languages. So whenever you're building something, you had to basically say, okay, I'm using C#, can I can I do it on Google Cloud? Well, it's 3.1, and now C# is 6, right? So you can't do it. With Java as well, it's only up to 11. I think this might be updated recently. But basically, there still is this table that you need to pay attention to. You can't just run any language and any version of that language. And when you look at these functions, they were mainly HTTP driven. So usually it was the HTTP or HTTPS that triggers your function. And on Google Cloud, the first generation of cloud functions, we also had some other triggers. For example, you could save a file to cloud storage, and that could trigger an event, or you could push a message to a PubSub topic, and that could trigger an event. So these were handful triggers that we provided, but they were very limited. Like you couldn't trigger your function in many ways. It was only like 4 or 5 different ways. And when you look at the resources that you have around these functions, they were also limited. Again, giving an example from Cloud Functions Generation 1, it was HTTP based, so that was the main protocol, and you couldn't do anything in the background. You had to do everything within the HTTP request thread. The processing time was limited, so by default, you get 1 minute to do your work, and then you can change that up to 9 minutes. So it was for small tasks that you can reply back quickly, but not for batch processing, for example, where it can take hours or days. And the memory and CPU you get was also limited, like 8 gigs and 2 CPUs. So for small things, it worked, but for anything bigger, you were out of luck, basically. By the way, I'm giving most of these examples from Google Cloud because that's what I know. But this is true for other cloud providers as well. And as we go along, I'll try to give examples from them as well. But these points, they apply to pretty much all the cloud providers. And we also had this cold start problem. The concurrency was 1, meaning when a request came in, you had to handle that in a cloud function. So we had to create the cloud function. When the second request came in, you had to create another cloud function. So it was 1-to-1. And because of this, if your cloud function wasn't starting up quickly, the users would notice that, right? Because every time they made a request, that would they would have to wait a little bit for the function to be initialized, run, and respond back. So this cold start was there for a while until we solved it later. And then once you start having multiple functions, then you need to start thinking about how do you want to group them together, right? First of all, on AWS, you couldn't have a function, a public endpoint function. So you couldn't have a function with a public endpoint. So what you had to do was you had to deploy your Lambda, and then you had to use the API gateway on AWS to make it public, so to create a public endpoint for that. On Google Cloud and Azure, I think you can have public endpoints from the beginning. But then, if you are building an API, for example, usually you need multiple functions because functions, by default, they handle one path, right? And in an API, you have multiple paths. So how do you do that? So what you do is you have multiple functions, each handling a single path, and then you group them together using some kind of an API gateway. So on AWS, API gateway was introduced early on because of the limitation of functions not having public endpoints. But then on Google and Azure, you also had API gateway and API management. Basically, these things, they all helped to group your HTTP-based functions together into an API. By the way, the AWS changed this now, so that when you deploy an AWS Lambda function, you can have a public endpoint, so you don't have to use API gateway anymore. But this was a very recent change, I think this year. All right, so in this first phase of serverless, we had limited languages emergence, so you couldn't run anything you want. We had limited triggers, so it was mainly HTTP based with a handful of other storage or PubSub kind of triggers, but it was quite limited. We had limited execution model, time and resources, so the function had to be small, it had to answer quickly, it had limited memory and CPU. We had this cold start problem because of one-to-one concurrency. And I didn't mention this, but also there was not much local development, right? So if you wanted to build a function locally and test it out locally, there wasn't much support for that. So you had to kind of deploy your function in the cloud and call it and see if it works. And we had some grouping for the HTTP functions, but there was nothing complicated. It was just basically a way to group them, but you couldn't do more complicated orchestrations or anything like that. So this was a good beginning, but it was very limited for the things that you wanted to do. So it was for very small microservices that did very quick things, but that was pretty much it. Now, in the next phase of serverless, we started seeing containers coming into the picture. So let's talk about that. Now, if you remember, there was a time where we had two parallel worlds. On one side, we had this serverless stuff coming up with functions. And what serverless enabled us to do is that it allowed us to go fast because we don't have to manage any clusters or machines. It's just the code that you need to think about. But at the same time, we started having containers. And containers allowed us to create a context that we can replicate everywhere, right? So you define any language, you basically use any language you want, you can use any library you want, and you define this context in the form of a Docker file, basically. And then with that context, you can run the context locally on your machine, or you can run it in the cloud as well, and you can rely on that context to be the same. So we had things like Kubernetes and Knative and that basically what people use to run containers. And we had these two worlds against each other, right? Serverless for velocity, but then you had containers for flexibility of choosing whatever language you want. But there was no overlap, right? So if you wanted to use containers, you had to basically learn about Kubernetes, which is not easy. I mean, if you look into Kubernetes, there's a lot of concepts that you need to learn about. And then you need to think about a cluster, a Kubernetes cluster, right? So you need to set that up. You need to maintain that. I know there's Kubernetes engines on Google Cloud and other clouds that makes it easier, but you still need to think about that cluster, right? But thankfully, there are tools, well, services that basically try to make running containers as if they're like serverless functions. So these services like Cloud Run, for example, on Google Cloud, or AWS as App Runner, Fargate, Lambda, or container instances on Azure, they are different. They're not one-to-one the same, but all they're trying to do is, make it easy so that for you to run containers in a serverless way, so that you don't have to worry about the underlying cluster or infrastructure. And when you look at Cloud Run, it's based on a project called Knative. It's an open source project that basically brought serverless containers on Kubernetes. So if you want to run containers on Kubernetes and not worry so much about the cluster, you can use Knative. And then Cloud Run is the managed version of that on Google Cloud. So when you use Cloud Run, there's not even a cluster, basically. You don't see a cluster. You just say, here's my container, deploy your container, and it's deployed, and it's auto-scaled like a function. It's priced like a function. So if no one uses your container, you don't pay for anything. So it's basically like a function, except it's a container, which means that you can define what the container is. And you can basically define your own runtime. You don't have to depend on the runtime of the function that you're using. So that's the big difference between serverless functions and serverless containers. But this container, it cannot be anything, right? Because, I mean, as you know, in containers, you can pretty much run any kind of code. But these containers, they need to basically adhere to some container contract. If you look at, again, on Cloud Run, this has to be an HTTP-based container. So you need to listen on 000 and on port variable, which is port 8080. This HTTP server has to start within 4 minutes. So it cannot be like this huge application server that we used to have back in the day that would start in like 10 minutes. It can't be that. The request time, so how soon it needs to respond, is now 5 minutes instead of 1 minute to functions. And you can increase it up to 60 minutes. So as you can see, the request time is increasing now. So you can run things for like an hour, which is pretty decent. It's still stateless containers for auto-scaling purposes. but you can only do things within the request. So within the request thread, you can do computation, but you cannot have background threads still. And when you look at the resources, you have more resources now, like up to 4 CPUs and 8 gigs, so things are getting bigger and more resources, more concurrency, and I'm going to talk about this in the next slide, and they're auto-scale from 1 to 1,000 containers. And one biggest difference was that, since this is an HTTP server, it can listen on multiple paths. So if you want to build an API, you can do it in a single container instead of having to deploy multiple functions and having to have API gateway. So that's also one difference between containers and functions. And when you look at concurrency, remember in generation 1 of Cloud Functions, it was 1-to-1, and we had cold start issues. But in generation 2, and also in Cloud Run, you have concurrency 80, meaning you can handle 80 requests at the same time in a single container. So what this means is that this cold start problem is much improved. It's not gone away, because for the first request, you still need to create the container, so it's still there. But the fact that a single container can handle multiple requests makes this cold start problem less likely, okay? So that's number one. And the number two is that there's also this notion of minimal instances in Cloud Run. And this is set to 0, meaning if no one uses your Cloud Run, it scales down to 0. But if you want to set this to 1, that will run as one container at all times, whether someone uses or not, right? So with that, with 80 concurrency plus some minimal instances always running, you don't run into cold start problems, most of the time. It can still happen, but most of the time, you don't run into it. And at this stage, we also started seeing some improvements on local development. So since we are running containers, we can run Docker locally and see how it works. We can use build packs, which is an open source project to convert your source code into containers without having to write the Docker file. On Google, there's something called Functions Framework that allows you to run Google Cloud Functions locally if you use this framework. And there are emulators for different services, like for PubSub and Data Store, for example, so that if you want to do some testing, you can use these emulators locally. And also, there's local stack on AWS that tries to mock all of the AWS services so that you don't have to actually call the actual service in the cloud. And I'm sure there's more stuff here, but I'm just giving you an example of basically some tools and things that came into play that made local development much more sustainable at this stage. And then I think I mentioned all of this. So at this stage, we had things running longer with bigger machines, and then we had build packs to take our code and make it into a container. So it wasn't a big deal to run containers anymore. And also, we started seeing richer protocols, right? I mean, so far, we only had HTTP-based services. But with containers, we could use WebSockets, so more real-time connectivity. We could do server-sent events. And we could also use gRPC. gRPC, it's an open-source encoding protocol that makes the communication between client and server much more efficient compared to JSON. So you could use that as well. So as you can see, the protocols are getting more richer, more real-time, and more efficient at this stage. And we could also start doing some basic orchestration. So let's say you want to deploy a service, it's serverless service, but you want to call it on a certain day at a certain time, right? You could use services like Cloud Scheduler on Google Cloud to configure that. And on AWS and Azure, it's called Cloud Watch and Scheduler. But basically, this allows you to do a little bit of orchestration of your service. Or if you want to do a task-based orchestration, you can use something called Cloud Tasks on Google Cloud, where you capture what your task is, put it in a queue, and then that queue calls your service at the rate that you define. And again, on AWS and Azure, there's other services like SQS and Service Pass to do this kind of stuff. But what this enables us to do is that it's basically, we have our code running serverlessly, but we also had these basic orchestration services to call our service in either based on a schedule or based on some kind of task-based queue. All right, so what was the state at this? What was the state of serverless at this phase? Now we can use any language and version with containers. The triggers are limited. It's mostly HTTP based and a handful triggers. The execution model time and resources are increasing, so we have bigger resources and longer time to do things within our serverless functions or containers. Cold start is not a problem anymore for the most part, even though it can still happen, but not as much. Local development is not an issue. And yeah, we had the grouping before with HTTP, with API gateway, but we also have some options for orchestration with schedulers and tasks and things like that. And this takes us to the next phase of serverless, where we started seeing expansion and integration of serverless in pretty much everything. And this is the phase that we are in, I think. So here, so once you start having multiple services or containers running serverlessly, at some point you need to figure out how do you organize them and how do they talk to each other, right? And there's basically, well, there's three different ways of doing this. One way that I'm not showing here is that you could have your services call each other directly. So you have service A calls service B calls service C. This approach is not here because it's not a good approach. The reason being is that, you know, if service A needs to know about service B, you need to kind of get that information into service A. And then every time you need to change something about service B, then you need to think about service A as well. So it's not a good approach to have this direct calls between services. Now, instead of doing that, what you could do is you could use events for communication. So in this event-based model, also known as choreography, you have an event bus in the middle, and the services, when they finish their work, they just send an event to that event bus. So service A finishes its work, it says, you know, finish work A, and that will go to the event bus. And actually, this diagram is a little bit wrong because it implies that, you know, service A sends the event to service B. It doesn't really send it to service B. It sends it to the event bus, and the event bus routes that. So whoever is interested in that event. So service A's event, maybe service B is interested, it will get that event, and it will act on it. And when it's finished, it will send another event. So in this event-driven approach, you have services that are loosely coupled. They don't really know about each other, and they don't care about each other. They just communicate indirectly with events. So that's the good thing about event-driven systems. But the bad thing about event-driven systems is that once you have a lot of services, let's say, you know, 20, 30, or 100 services, then it becomes quite difficult to trace what's happening in your system. You know, if something doesn't work, you don't know immediately which service didn't send the message, or maybe which service didn't process the message, right? So even though it gives you a lot of flexibility to, you know, deploy services and update them in a loosely coupled way, you lose a little bit of monitoring and traceability when you're using events. Now, on the other hand, what you can do is you can also use what's called an orchestrator, an external service that orchestrates the call in the order that you define. So here, Google has something called workflows, for example. Here you define at workflows how your services should be called, and an orchestrator will call those services in the order that you defined. Now, the good thing about this is that now you have a central place to define how things should work, and then things also become really easy to monitor because since orchestrator knows how things should work, if something doesn't work, let's say it makes a call to service B, you will see that immediately that service B didn't return the call. So it becomes easier to monitor. So you have these two approaches like choreography or orchestration, and depending on what you want to do, one is better than the other usually. So for loosely coupled architectures, this is better. But for more structured architectures, orchestration is better. And the beauty of orchestration is that your services are still independent, so they are still independently deployed, but you kind of bring them together into what I call a temporary monolith, basically using an orchestrator. And when you look at cloud services, on Google Cloud, there's Event Arc and PubSub for event-driven architectures. On AWS, there's SNS, Event Bridge. On Azure, there's Event Grid, Event Hubs. So there's a lot of option here. So pick and choose, depending on where you're running. Pick and choose the service that's available to you. And what Event Arc does, Google's eventing service, is that Event Arc basically increases the triggers to your functions and containers. So you not only get your function or container triggered by Google Cloud sources, but have external third-party services also calling your serverless services. So this increases your triggers from just a handful to basically hundreds, maybe even more services that can call your service. And when you look at orchestration, as I mentioned, workflows is what Google has for orchestration. So imagine you have this flowchart where you have an ordering system. You can take this flowchart and you can actually convert it into a workflow definition, and workflow will make these calls in the order that you define. And on AWS, there's step functions for this, and then on Azure, there's durable functions for orchestrating functions, but then there's also logic apps to orchestrate functions and also external services and many, many other things. So again, the point here is that if you want to do orchestration, there's services in each cloud to do that, so you don't have to do this yourself. And when we look at workflows, workflows allows you to orchestrate and integrate services. So if your code is running on Cloud Run or functions, you can take that and put it into your orchestration. If you have Google APIs that you want to call, you can put that into your orchestration. And you can even include external APIs in your orchestration. So it allows you to bring all of those together into an orchestration that you can define. And actually, let me show you an example of this. Let's say I want to chain some services together. So I have service A, service B, service C, service D running in different places, and I want to bring them into an orchestration. How do you do that? Well, I would use workflow, and my services, I don't know if you can see this, but my services, my first function, it's a cloud function that's called random gen. It generates a random number. So I deploy that. It's a Python function. Then the second function is another cloud function called multiply. So given some numbers, it multiplies them. So it's something very simple. And then the third function, it's an external function from Math.js. So in Math.js has an API where you can pass in an expression. And this expression is basically a mathematical expression. And it gives you the result back. So in this case, we are using the log function from Math.js. And then the fourth service is it's a Cloud Run service. So it's a container that's called floor that takes the floor of a number. So if you give it a number, say like 6.86, it will give you 6, basically. So as you can see, we have two cloud functions in Google Cloud, one external function running somewhere else, and then one Cloud Run container that's running a container service, basically. So to bring this together, what you need to do is you create a workflow definition file. This is in YAML, but it can be in JSON as well. And then you define your steps. What should happen in this orchestration? Now, in the first step, we called it random gen function. We are making an HTTP GET call to the cloud function. So this call is made by workflows, and the result will be captured in random gen result, right? So that's the result that will come back from the service. Now, in the next step, we are making an HTTP post call, and the URL is, again, another cloud function, but the body has an input from the previous result. So we get the result from here, and we parse the body of that, and we look for random. That's where the number will be, and we'll provide that as input, and the result will be captured as multiply result. Then the third one is the log function, and you can see that here we are making a call to Math.js, so external function, and we are passing an expression. This is a query expression, and we are, again, using the result from previous step, and then parse the body and the multiplied, and look for the multiplied, and then pass that as an input to the log function. And finally, the last one is a call to Cloud Run service, which is running a container, but it's an authenticated service, meaning it's a private service. So that's why I have this authentication here. And then the input is again from the previous result. So we are basically making the calls, capturing the result, and passing the result into the next step. So that's how you define it. And then you deploy to Google Cloud. And then I already have it here. So if I look at service chaining, if I look at source, you can see this is the same source I show you. But the nice thing is that you also get a visualization. It shows you how things should be called. So it's very simple, just a chain. And if I want to execute, I'll just come here. You can provide an input, but in this case, we don't have an input. The first function generates the number. So I will just execute this. And then now the whole chain is being called. And you see that there's the input, but then once we finish, we should see an output, which will be basically a number. So you can see that the output is a body with 4. So that's the output. And I'm also outputting some HTTP codes and headers and things like that. So that's how you can kind of do orchestrations I mean, this is a very simple example, but you can imagine the kind of things that you can do here with workflows. Now, what I also seen is that once you have event-driven systems and once you have orchestrations, you don't have to actually choose one or the other. And what usually happens is that I see people kind of combining them together as it makes sense. For example, in this example, I want to build an image processing pipeline, right? So I want users to upload some images to a cloud storage bucket. And then once that image is uploaded, I want a number of functions to process that image. Now I have 4 functions. The first function is a filter function that will filter the images, whether they are safe or not, using machine learning, okay? So if the image is safe, then it will pass it to the labeler function that will, again, use machine learning to extract the labels out of the image. And then it will call the resizer function that will resize the image to a size that we determine. And then finally, the watermarker function will get the labels from this function, and it will get the resize image from this function, and it will create this new image that has the image and the labels on top as a watermark, and it will save it to the output bucket. Now, when you look at this, I put these 4 functions into an orchestration. And the reason for this is that, these functions, they need to be called in a certain order, right? First, it has to be filter, then it has to be labeler. It doesn't make sense for them to be loosely coupled, or the order doesn't change. It always has to go this way. And actually, the input of one feeds to the output of one feeds to the input of the other, right? So because of that tight coupling in these functions, it makes sense to make them into an orchestration. And that's what I did here. But then to call this orchestration, it doesn't have to be a direct call, right? It doesn't have to be tightly coupled. Instead, I used an event-driven approach here. So I use event arc to, whenever user uploads a picture, it will basically generate an event. That event will go to workflows, and then workflows will execute our chain, right? So if you want to look at this, it's on GitHub. Again, you can get the links from my presentation. Just to show you, maybe I'll show you in here the workflow, how it looks. So if you go back, image processing, then look at source. So I don't know if you can see this, probably not. So let's go back. Yeah, so this is the workflow. It will receive an event, then we'll log the event. Then from the event, we extract the information about the file, the name and the bucket information. Then basically, we just call the filter function, and the filter URL will be replaced, but basically we are calling the filter function and get a response. And then we check the safety. So the response has a safe flag in it. So we check if the safe is true. So you can see I can do conditionals within my orchestration. So I don't have to do that in the code. And then if it's safe, we go to the next step. But if it's not safe, we end our orchestration. So then we call label to get the labels. Then we call the resize to get the resize image. And finally, the watermark is called with the resize image information and also the labels, right? And then the final result is just HTTP code from all the functions. I mean, you can return whatever you want, but here I'm just returning the HTTP codes. So just to see that it works, and I think I still have 5 minutes or so. So image processing, well, I need to upload an image just to see that it will trigger. And then so I have a bucket here, input. I think it's this one. Well, it's one of them. Let's try this one. Okay, I'm not too sure, but so let's upload this picture. All right, so this will trigger the event, and then this event will go to, and just to be on the safe side, where did I upload? So I uploaded here, right? Let's upload to the other one too, because I'm not sure which one. I think it might be this one, to be honest. Let's upload the same picture here. All right, so if that triggered, we should go to workflows. And if you look at image processing, you see that there's an execution that's running. And if we click on that, the input is an event, so with the bucket and file information, and it already finished. So if you look at here, the execution is succeeded. The output is just filter, label, resize, watermark 200, meaning they all return correctly. And just to look at the image, output files. So if you look at here, then we see some images, and I think this is the one that I uploaded. So this is the first, you see that this is the labels, this is the resize image, and this is the resize and watermark image. So if I click and look, all right. Well, there you go. So the picture with water, cloud, sky, so it picks the top 3 labels and just puts as a watermark on top of the image. So you see how you can combine event-driven and orchestration as it makes sense. Now, to finish it off, I also started seeing where we combine serverless with servers. So let's imagine, for example, you want to run a long-running operation. Like let's say you want to calculate a prime number that can run, for days, weeks, or even years, right? For that, you cannot use serverless because serverless has limitations, like 1 hour or maybe a little bit more, but it has limitations. So what you can do is that you can actually create a VM, run a container on that VM as long as you want, and then you can configure that VM to have as many resources as you want. And then in the end, tear down the VM and get the result. We will get the result and tear it down, right? And you can do all of this, again, using orchestration. So you can use workflows to automate this, creating the VM, running the code, getting the result, and shutting down the VM. So I have this example here. I'm not going to show it here right now. But basically, what this enables you to do is that you just run an orchestration, just say, just run this for 2 days, and it will just do it for you. In the end, you just get a result back. But behind the scenes, you are using serverless. So it's combining serverless with what I call serverful, as it makes sense. And there's also a new thing called Cloud Run Jobs. So again, so far, we've been dealing mostly with HTTP-triggered services. But let's say you want to do background tasks on a schedule, right? For that, now there's something called Cloud Run Jobs that enables you to run a container that's not triggered by HTTP. It just gets called. It does its job, and then when it's done, it will just be finished. And yeah, so if you want to do like what I call the run to completion containers, there's also options for that now with Cloud Run Jobs, and also on AWS, I think they have something like that as well. All right, I think I'm almost out of time, but the point is, I think most of the stuff that we talked about, they're now possible with serverless. And even if it's not possible, even if you need the customization and extra resources of a virtual machine, you can still use serverless orchestration to manage that. so that you don't have to make developers deal with infrastructure directly. It can all be automated in a serverless way. So I think we are in a much better shape today. And then we didn't even talk about these other serverless/managed data and services, because we mostly talked about running your code. But once you have your code running in a serverless way, you should also think about, okay, what about my data layer? You know, if I want to run a NoSQL database, there are serverless options. So you don't need to set that up or run yourself. Or if you want to use cache, there is things like memory store and other services that allows you to have a cache where you don't need to worry about services or instances or scaling and things like that. So keep that in mind as you're building services. Like it's easy to choose a wrong service and just have to manage all this stuff. Always look for the serverless option. And if you cannot find it, maybe then start thinking about how to do it in a non-serverless way. But can you make it easy using the serverless orchestration or eventing or something like that? So I think I'm almost out of time, but this is the takeaway from my talk. I think serverless is now the default way of running code in the cloud. Use it if you can. If not, try to automate things using serverless. The presentation is on speaker deck. And if you go to my presentation, you will see the links for GitHub as well. Yeah, so thanks very much for listening. And I'll just wait if you have any questions. Thanks very much. So any questions? Yes, well, let's wait for the microphone.
Hi, thank you so much for the presentation. I'd like to do a couple of questions about, specifically about your examples that you showed from your orchestrator before. So I saw that you had authentication in one of the orchestration steps. I wanted to ask, how does it know like what credentials to use? Does it go to another Google Cloud Platform service to get the credentials? This is kind of a far-fetched example maybe, but like, can you combine different URLs from different cloud providers, or is this a Google Cloud Platform exclusive service that you can only use with Google Cloud Platform URLs?
Okay, yeah. So for the first question, how does it know how to authenticate, basically? Well, when you deploy a workflow, you deploy with a service account. And that service account has roles. And then from those roles, you basically are allowed to do certain things or not. So in this example, we were calling Cloud Run. So that service account has to have Cloud Run invoker role. And if you have that, then you will be able to make that call. So that's that. Now, the second question was, can you combine URLs from different cloud providers? Yes, you can. Workflows can call any URL you can call from Google Cloud. You can include in workflows. So it has to be accessible from Google Cloud. But as long as it's accessible, yeah, you can include it in your orchestration. It doesn't discriminate against any cloud provider or any URL as long as it can access to it. Yeah. Any other questions? Yes.
Hello, thank you for the opportunity.
Yeah.
I would like to ask if we could use stateless, serverless for something like streaming video, or does it run into the limitation of 1 hour?
Well, I mean, yeah, right now you have this 1 hour limitation on Cloud Run. So if you can process things within 1 hour, it will work. But anything more than that, you have to find a way to kind of cut it to 1 hour and then maybe continue later, like another Cloud Run instance.
Would it still scale automatically if multiple users use the same endpoint at the same time?
Yeah, I mean, Cloud Run auto-scales by HTTP calls. So the more HTTP calls you get in, the more it scales up to a limit that you define. So there's this max instances limit. And I think it goes up to 1,000. So you can set it up to 1,000. So you can scale up to 1,000 containers if you want. If you need to scale even more than that, then you need to open a ticket to increase those limitations. So there are soft limitations, but they do exist. Yeah. One more question?
What do you think are the next steps for serverless for stage 4?
Yes. Yeah. What are the next steps? I think basically everything by default will kind of run in a serverless kind of operational model, right? So if you have databases, by default, you would expect them to kind of run in a serverless way, like meaning you don't have to provision them, you don't have to do capacity planning, you don't have to pay for the full price all the time. So maybe you would pay for the data that you have in there or the way you access it. So that model that we are used to in running our code, I think it will infiltrate to other things like data layer and other services. And that's what people will basically take it as granted. So serverless will be the default way of running things. That's my opinion. Any last questions? Yes? No? OK. Well, thanks very much for coming. And if you want to talk more, I'm here for the rest of the conference. So yeah, thanks very much.